Hello, I'm Paul Robertson, also known as Robby, and I'm a Technical Client Manager here at SAS, and in this session we will be taking a closer look at insights and modelling within SAS Viya. The insights and modelling can be scripted and parameterized using SAS visual interfaces and programmer workbenches, including SAS Studio, Jupyter Notebook and RStudio. The process can be simplified and automated using templated pipelines, interpretability charts, hyperparameter auto-tuning techniques, and natural language explanations. The framework provides discrete processes and tasks that can be shared across one team or multiple teams that is responsible for the insights and modelling lifecycle. The first part of the process is viewing insights from previous analysis. New insights can be created from the table and graph objects, including tabulations, heat maps, and map visualizations. Controls like drop-down lists and sliders enable applications to be created and shared. The main benefit of SAS Viya is the array of analytics, statistical techniques, and its machine learning algorithms. These include forecasting, network analysis, clustering, decision trees, regressions, recommendation engines, random forests, gradient boostings, neural networks, and support vector machines. Decision trees is one of the most versatile and comprehensive machine learning algorithms and includes statistical techniques like variable importance, confusion matrix, lift charts, and ROC charts, as well as fit statistics like the Gini index to determine the class distribution. The interactive decision tree is easy to explore, to analyze, and to explain to business stakeholders. The decision tree leaf segment can be saved as a new variable, and the segment variable can be further analysed with other modelling input data. Geographical representations provide insights that are not discernible through tables and charts alone. Maps can highlight patterns and densities to help understand relationships between the input data and its environment, including segments created using statistics and machine learning algorithms. SAS Viya has integrated Esri mapping capabilities to enable geospatial features, including geocoding, demographics, and drive time calculations. Models can be duplicated using the same data inputs and assumptions into alternative models, including gradient boosting and random forests, with access to the same statistical insight charts and fit statistics. Model options and hyperparameters can be changed manually and the results assessed individually using the statistical charts and outputs. Alternatively, SAS Viya can auto-tune the models and select the most optimal values for the model parameters, including the number of trees and leaf size. Auto-tuning significantly improves the accuracy of the resultant model and reduces the modelling duration. SAS Viya provides automated model explanations that depict the relationship between the target variable and the model input variables and include statistical inferences to understand how the input variable affects the target probability. The second part of the process is building predictive models from the insights and analysis previously undertaken. SAS Viya manages and depicts the flow of analytical tasks within pipelines. Ensemble models can be created to obtain better prediction performance than any constituent model alone and can reduce the generalization error of the model's prediction. Model comparison results selects the champion model using the chosen fit statistic like the KS statistic or the misclassification rate. Other statistics are available to ensure the champion model is robust and fit for purpose. Modelling projects can contain one or more pipelines, and the pipelines simplify and automate the modelling workflow. Machine learning models like random forest can be added to an existing pipeline to ensure that the chosen model has been tested against potential alternatives. Before running a pipeline and its associated analytical tasks, the model parameters can be tuned independently or auto-tuned by SAS Viya. To support model interpretability, SAS Viya can produce various outputs to explain and understand machine learning algorithms, including partial dependency plots. The node results for each model includes error plots, variable importance tables, model score code, the model input and output variables, plus the training code to validate the model. Model assessment plots show the accuracy of the model, including the differences between the training data and the validation data. But as important are the model interpretability charts, like the partial dependency plot and the independent conditional expectation plot, which depicts the distribution of the model inputs to the target prediction. Python and R code can be integrated into a modeling pipeline to execute pre-processing and supervised learning tasks. Data is shared with Python and R using CSV files and data frames, and the modeling variables are converted to local variables to support a multi-language modeling framework. SAS Viya provides pipeline templates to simplify the modeling process. These include templates for classification targets, interval targets, risk modeling, forecasting, segmentation, feature engineering, and natural language processing. Templates can be modified and saved in the Exchange to share with other analysts to standardize the modeling approach. SAS Viya can dynamically build a pipeline based on the model input data. The automated process selects the most appropriate model by profiling the input data, generating and evaluating candidate branches, and running pre-processing features like data cleansing. The pipeline comparison report compares the champion model for each pipeline to see which model provides the best result using the model assessment and fit statistics. The Insights report provides a notes section to share findings with other analysts, as well as pipeline and model comparisons to assess the project as a whole and the champion model's incremental benefit over the challenger models. The charts include detailed descriptions on how to interpret the model results. Finally, the selected model can be registered to SAS Viya's modeling catalog for independent validation and testing, or published directly to a runtime engine including SAS, Hadoop, Teradata, or an API call within an online system. The Insights and Modeling Framework within SAS Viya provides scripting and visual interfaces to simplify and automate the integration of SAS, Python, and R. Insights can be automated and combined with the array of controls, tables, geographics, analytics, statistical techniques, and machine learning algorithms. Segmentations and statistical inferences can be saved and analyzed with other modeling inputs to highlight patterns and densities to understand data relationships further. Model options can be modified individually or optimized using the auto-tuning capabilities of SAS Viya to increase the modeling accuracy and reduce the modeling duration. Model assessment plots and machine learning interpretability charts depict the distribution of the model inputs to the target prediction to simplify and explain the analysis to business stakeholders. Analytical tasks and flows are managed and depicted using pipelines and can be created from previously undertaken insights. SAS provides pipeline templates that can be customized and shared within the Exchange. SAS Viya can dynamically build pipelines based on the model input data to support model collaboration and best practice. Python and R code can be integrated with SAS pipelines to support a multi-language modeling framework. These models can be compared and analyzed using the statistical insights, assessment charts, and fit statistics within the SAS Viya framework to select the most appropriate champion model for further testing or direct deployment. If you would like further information on this topic or any other topic, please contact me at paul.robertson@sas.com or via LinkedIn or via Twitter. Thank you very much. Diolch yn fawr.